You've seen rain, you've seen lightning, but nature has secrets. Phenomena so rare that entire lifetimes pass without witnessing them. This is the Natural Phenomena Iceberg. 6 layers, from the everyday to the mythical. How deep can you go? How many have you seen? We start at the surface. Things so ordinary, we forget they're miracles. Blue sky. The sky isn't actually blue, it's colorless. Sunlight scatters through billions of atmospheric particles. Blue wavelengths bounce more than red, painting our world in azure. Every day, you're watching a light show. You just don't realize it. Those same particles that color the sky also reveal something else when obstacles block the sun's path. Sunbeams, crepuscular rays cutting through trees and clouds like searchlights. The air you breathe is full of debris, dust, pollen, microscopic particles. Light makes them visible, turning empty air into glowing corridors. And suspended within that same air? Clouds. Billions of water droplets held aloft, weighing millions of pounds yet floating effortlessly. When they grow thick enough to block light, they turn gray. These aren't decoration, they're water, waiting to fall. When they finally release that water, we get rain and snow, precipitation, the planet's recycling system. That raindrop on your windshield has been falling for billions of years, older than civilization itself. Snow takes it further, frozen water crystallizing into geometric patterns. No two snowflakes are identical. But water isn't the only thing that falls from above. On any clear night, if you're patient enough, you'll see meteors, shooting stars, rocks from space, burning up as they hit our atmosphere, releasing energy as bright streaks. Space debris turned into light shows, visible every single night if you just look up. Look up during the day though, and you might witness something more violent. Lightning, the electrical discharge between charged atmospheric regions. Cloud-to-cloud flickers dance inside storms, but cloud-to-ground strikes are the killers. Each bolt 5 times hotter than the sun's surface. You've probably seen dozens. Each one could have ended a life. When the sun finally sets, there's one more common miracle most people miss. Turn around after sunset. Look opposite the sun. You'll see the belt of Venus, a pink band stretching across the horizon where sunlight scatters through the atmosphere one last time. Below it, Earth's shadow rises like a dark tide. This happens twice every day. Most people never turn around to look. Fire, another form of light and heat, completes this layer. Fire is rapid oxidation. Fuel consuming oxygen so fast it glows, producing flames hot enough to turn gas into visible light. Humanity tamed this force for survival. But nature never needed our permission to wield it. You've seen all of these, but now we descend. Layer 2. Uncommon phenomena. Not every day, but if you pay attention, you'll see them in your lifetime. Light bends. And when it bends through the right medium at the right angle, magic happens. Rainbows. Sunlight enters a raindrop, refracts, reflects off the back surface, and exits, splitting into the spectrum. Red on the outside, violet on the inside. The rainbow exists only from your perspective. Move 10 feet, it moves with you. It's a personal light show drawn between you and the storm. But rainbows have secrets. When light reflects twice inside those droplets instead of once, you get a double rainbow, a secondary bow, fainter, with colors reversed. The dark gap between them is Alexander's band, where less light scatters. If you see one rainbow, always look for its ghost trailing behind. And if that rainbow forms near sunrise or sunset, something stranger happens. The sun sits so low that the atmosphere filters out everything except red wavelengths. The entire bow turns crimson. A red rainbow, also called a monochrome rainbow. All the colors die except one. It's a rainbow bleeding out. Light doesn't just bend through water. Temperature itself can become a lens. When the ground is superheated and the air above stays cool, light refracts, making roads appear wet when they're bone dry. Mirages. Your eyes aren't lying. Light is. At night, if the moon is full and clouds are thin, look closely at the lunar surface. You might see a lunar corona, diffraction of moonlight through tiny water droplets, creating a colorful ring around the moon. Most people never look at the moon long enough to notice, but the moon does more than wear halos. When Earth passes directly between the sun and moon, our planet's shadow falls across the lunar surface, a lunar eclipse. The moon doesn't go dark though. Earth's atmosphere bends red light into the shadow, painting the moon crimson. It happens once or twice a year. Ancient peoples thought it was an omen. They weren't entirely wrong. It's a sign that three celestial bodies have aligned perfectly, if only for an hour. During the day, especially in winter or when it's snowing, the sun wears its own crown. Ice crystals high in the atmosphere refract sunlight into a 22-degree halo, a faint ring circling the sun. And along that ring, two bright spots often appear. Sundogs, also called parhelia. The sun gets companions, two false suns flanking it on either side. Ice crystals aligned horizontally in the air create this effect, making it look like three suns burn in the sky. Sometimes precipitation doesn't fall gently. In powerful supercell thunderstorms, water droplets get caught in violent updrafts, cycling up and down, freezing and accreting layers like an onion. Eventually they fall as hail, chunks of ice, sometimes growing to baseball size or larger, what meteorologists call gorilla hail. It's not just frozen rain. It's a warning that the storm above is monstrous. And where there are thunderstorms, there is lightning, but not always the kind you can hear. Heat lightning occurs when a storm is so far away, beyond 15 miles, that the sound can't reach you. Thunder fades into silence, but the sky still flickers. Summer nights are full of this. Distant electrical violence, perfectly silent. The storm is there, you just can't hear it scream. Lightning itself has a rarer cousin. Most lightning strikes downward from a negatively charged cloud base, but positive lightning strikes from the top of the cloud, where positive charges accumulate. These bolts are longer, louder, and more powerful. They can strike miles away from the parent storm, appearing under blue sky. The storm doesn't need to be overhead to kill you. Winter brings its own special phenomena. When a powerful blizzard builds enough instability, it can actually produce lightning. Thunder snow. The combination of heavy snow and electrical discharge creates a surreal, muffled rumble. Imagine a blizzard. Now add electricity. But perhaps the most spectacular light show requires no storm at all. When charged particles from the sun collapse with gases in Earth's upper atmosphere, they ionize, releasing energy as light. The aurora. Typically green from oxygen, but intense storms can produce red, purple, and blue. Northern and stranger lights. Aurora borealis and aurora australis. The sky dances with fire that doesn't burn, and we watch from below, tiny witnesses to solar violence made beautiful. Ice crystals create more than just halos and sundogs. High above, in cirrus clouds, hexagonal crystals can refract sunlight into an upside-down rainbow called a circumzenithal arc. It appears directly above the sun, a smile of blue and yellow in the sky. It's more common than you'd think. You just rarely look straight up. At night, those same ice crystals can do something else. When ground lights, street lights, car headlights shine upward and reflect off ice crystals in the air, they create light pillars, vertical beams shooting into the sky. Some people mistake them for UFOs. They're not aliens, just frozen air playing tricks with artificial light. Not all vortices require storms. When the ground is hot and the air above is cool, thermal updrafts can spin into rotating columns of dust devils. They're common in deserts and flat, hot areas. Even Mars has them. These are baby tornadoes, born from heat instead of supercell rotation. Weaker, but still capable of flipping cars if they grow large enough. Over water, similar convection can create waterspouts, vortices that drink the sea. They're weaker than land tornadoes, but deadly to boats. Common in Florida, Louisiana, and the Great Lakes. When conditions are right, the ocean grows teeth. You might see these once, maybe twice. But now we go deeper. By the way, before we continue, if you like the sort of content I'm making on this channel, go ahead and hit that subscribe button. Would mean the world to me, y'all. Now, back to the video. Layer 3. Rare Phenomena. These are trophies. If you've seen one, chance chose you. We've talked about rainbows arcing through the sky, But sometimes, ice crystals create something that doesn't arc at all. The fire rainbow, technically a circumhorizontal arc, forms when sunlight refracts through horizontally aligned ice crystals in cirrus clouds. It's flat, stretching across the horizon, making entire clouds look like they're burning with rainbow fire. Some regions never see it due to latitude. Others see it multiple times per year. A rainbow that forgot how to curve. Fog creates its own version. When sunlight passes through extremely tiny fog droplets, the light diffracts differently, removing color entirely. What's left is a fog bow, a ghost white arc hovering in the mist, usually seen from plains or mountain peaks, a rainbow that lost its soul. At the exact moment of sunset, if your horizon is perfectly clear, the atmosphere can perform one final trick. As the sun dips below the horizon, atmospheric refraction splits the light into its component wavelengths. For 1 to 2 seconds, the green wavelength is the last to vanish, a green flash. Blink and you miss it. The ocean drinks the sun and burps green. We've discussed lightning striking downward and upward, but there's a third direction. Above the tallest thunderstorms in the mesosphere, brief electrical discharges ionize the thin air, creating red sprites, crimson flashes that last milliseconds, reaching towards space. They weren't discovered until 1989 because they're so fast. Lightning that strikes upward, beyond the storm, into the void. Some clouds exist at the very edge of space. Noctilucent clouds form 50 miles up in the mesosphere, where ice crystals condense around meteor dust or rocket exhaust. They're only visible at twilight, when the lower atmosphere is dark, but these high-altitude clouds still catch sunlight. They glow electric blue, rippling like waves on a frozen ocean. Clouds at the boundary between atmosphere and space. Moonlight is usually too faint to create rainbows, but under perfect conditions, a full moon, rain, and clear sky behind you, it can happen. A moonbow appears, usually looking white to the human eye, because our color receptors need more light. But cameras reveal the truth. The moon makes rainbows. You just can't see them. Mountains force air upward, and when that air is moist, it condenses into clouds. But when the wind is strong and steady, those clouds can take on bizarre shapes. Lenticular clouds, stacked like UFO saucers, smooth and stationary for hours. They hover in place even as wind screams past them. Nature's UFOs. Sometimes, if you're on a mountain peak above a fog bank, you can see your own shadow projected onto the fog below. Magnified, giant, with a colorful halo around its head. This is a Brocken specter with a glory, backscattered light creating a rainbow ring. Named after Brocken Peak in Germany, where hikers thought they were seeing ghosts or angels, you become the ghost. Above the stratosphere, in the thin air where meteors burn, another type of lightning emerges. Blue jets shoot upward from storm tops toward the stars. Blue, cone-shaped, moving at thousands of miles per hour. Only confirmed to exist in the 1990s. The storm reaches for space. And then there are tornadoes. For the average American, seeing one is rare. Most people never will, but about 1,200 form in the United States each year. Violently rotating columns of air spawned by supercell thunderstorms. Inside these storms, wind shear creates rotation. When that rotation tightens and extends to the ground, a tornado is born. They range from EF0, barely strong enough to snap tree branches, to EF5, where wind speeds exceed 200 miles per hour, and entire neighborhoods are erased. They are indifferent to whether you witness them. They don't care if you're prepared, and they don't follow rules. Some are even rarer. Some break every assumption we have. Layer 4. Very rare phenomena. Once-in-a-lifetime events. If you see these, you've been chosen by coincidence. We talked about positive lightning earlier, strikes from the top of the cloud. But there's a variant, so dangerous it has its own name. Bolt from the blue. These strikes exit the storm's anvil, travel horizontally for miles through clear sky, then arc downward and hit the ground. Hikers, golfers, beachgoers, all killed under sunny skies, miles from the visible storm. You can't hear thunder, you can't see the cloud, and then the lightning finds you anyway. Lightning kills from unexpected places. But there's another celestial ambush, one that announces itself but happens so rarely that entire civilizations rise and fall between occurrences. The total solar eclipse. The moon passes directly between Earth and the sun, casting a shadow on our planet's surface. For any single location, this happens once every 375 years on average. The path of totality is only 70 miles wide. Ancient civilizations thought the world was ending. Modern humans spend thousands of dollars traveling to stand in that shadow. The sun dies. Stars appear at noon. The temperature drops, and for 2 to 4 minutes, time stops. Then the sun returns, and you realize you've witnessed something your ancestors feared as an omen. Eclipses are predictable. Celestial clockwork we've learned to anticipate. Tornadoes are not. And tornadoes themselves have even rarer forms that defy every prediction model. Multi-vortex tornadoes contain multiple smaller funnels, subvortices, orbiting within the parent circulation. These vortices can have their own wind speeds exceeding 150 miles per hour, stacked on top of the main tornado's motion. They create pockets of extreme destruction within an already catastrophic event. Damage surveys find areas where houses are obliterated next to areas where they're only damaged. The tornado within the tornado. And on May 31st, 2013, near El Reno, Oklahoma, one of these multi-vortex monsters demonstrated what happens when a storm refuses to follow any pattern at all. The widest tornado ever recorded grew from 1 mile wide to 2.6 miles wide in 30 seconds. It had multiple subvortices spinning at 175 miles per hour, within a parent circulation moving at 55 miles per hour. Mobile Doppler radar measured winds exceeding 313 miles per hour, among the highest ever recorded on Earth. But the wind speed wasn't the deadliest part. The tornado was rain-wrapped, translucent, nearly invisible. It changed direction without warning, trapping storm chasers who thought they were safely positioned. It accelerated from 20 miles per hour to over 55 in minutes. Tim Samaras, a veteran storm researcher who had survived hundreds of tornadoes, died in that storm, along with his son Paul and colleague Carl Jung. They were the first storm chasers ever killed by a tornado. For 40 minutes, El Reno violated every rule experienced chasers relied on. It didn't just break records. It shattered the illusion that experience keeps you safe. Nature doesn't care how much you've studied it. Tornadoes kill through wind, but Earth has other ways of generating violence, forces that come from below rather than above. Volcanic eruptions themselves are rare to witness, but when a volcano erupts with enough violence, the ash plume itself can become a thunderstorm. Ash particles collide, building static charge until it discharges as volcanic lightning. Dirty thunderstorms, where the volcano spits electricity alongside fire, the earth bleeding light. The sun, too, has its violent outbursts. During particularly intense geomagnetic storms, amateur photographers in recent years have captured something unusual above the aurora, a narrow ribbon of purple and white light stretching across the sky. Scientists named it STEVE, Strong Thermal Emission Velocity Enhancement. Identified only in 2016, its mechanism is still unclear. It's not technically an aurora, but it appears with them. An aurora that isn't an aurora, discovered in an age when we thought we'd cataloged every light in the sky. Steve appears during strong solar activity, but every century or so, the sun doesn't just send light, it sends a weapon. A strong geomagnetic storm, Carrington event class, floods Earth with charged particles. Auroras appear at the equator. Electrical grids overload. In 1859, telegraph operators were shocked by their own equipment. Northern lights blazed over Cuba. The sun tried to destroy our technology before we'd even built much of it. If a Carrington-class storm hit today, satellites would die. Power grids would fail. We'd lose billions of dollars of infrastructure in minutes. The sun reminding us that we live at its mercy. We're near the bottom. The ice is black. Layer 5. Rarest verified phenomena. These are real, documented, photographed. but you will likely never see them. The sun sends geomagnetic storms, but fire can create its own atmospheric violence. Fire creates updrafts. We know this. Large wildfires create their own weather systems, pyrocumulonimbus clouds towering into the stratosphere. But in 2018, in Northern California, the Carr Fire crossed a threshold no wildfire had crossed before. It spawned a fire tornado. Not a fire whirl, those are common, just heated air spinning debris. This was a true tornado, rated EF3, with winds reaching 143 miles per hour, made entirely of flame. It moved with purpose, tearing through neighborhoods, uprooting trees, vaporizing cars. A fire inspector named Jeremy Stoke died trying to evacuate residents. It was the first time a tornado warning was ever issued for fire. Fire learned how to tornado, and it hunted. Fire can block out the sky when it burns hot enough, thick enough. But on May 19, 1780, New England experienced darkness that still defies complete explanation. A dark day. At noon, the sky turned black. Not an eclipse. This lasted over an hour, spreading across multiple states. Candles were lit in the middle of the day. Farm animals returned to their barns thinking night had come. People believed the apocalypse had arrived. The most likely explanation: massive wildfire smoke coagulated over the region, so thick it blocked the sun entirely. But the scale required, the perfect atmospheric conditions, have never been replicated. The sun vanished, and an entire region waited in darkness, wondering if it would ever return. Darkness from below. But sometimes, light appears where it shouldn't. At the very tops of the tallest thunderstorms, ice crystals normally sit still on the anvil of a cumulonimbus cloud, but on rare occasions, they suddenly realign and flash, responding to electrical field changes within the storm below. This is a crown flash, pulses of light shooting from the cloud's head, dancing and rippling like aurora on the surface of the storm itself. The cloud wears a crown of light, and the crown moves, alive. Clouds can create light, but so can visitors from deep space. Every few decades, a comet bright enough to outshine the full moon appears. A great comet, visible even in daylight. The last one, Comet McNaught in 2007, stretched its tail across the entire sky for observers in the southern hemisphere. Ancient people saw them as omens of war, famine, the deaths of kings. Modern astronomers see them as messengers from the Oort cloud, icy bodies from the edge of the solar system making their once-in-a-millennium journey past the sun. Once every 50 years, the sky grows a new star, and unlike every other star, this one moves, night by night, crawling across the heavens until it vanishes back into the void. Comets bring ice and rock, but sometimes the sky rains things that were once alive. Fish falls, fish, frogs, small birds plummeting from clear skies have been documented throughout history, most famously in Yoro, Honduras, where it happens almost yearly. The theory? Waterspouts or tornadoes lift aquatic life from ponds or oceans, carry them miles through the air, and drop them over land. Tornado debris can travel 100 miles. Why not life? The sky rains what it steals. Most meteors burn up harmlessly, streaks of light and nothing more. But on February 15, 2013, over Chelyabinsk, Russia, a 20-meter asteroid proved that space can still kill us. The Chelyabinsk meteor entered Earth's atmosphere and exploded with the force of 30 Hiroshima bombs. It was brighter than the sun. Its shockwave shattered windows across 6 cities. 1,500 people were injured, mostly by flying glass. Dashcams captured the entire event, a second sun rising in the east, then detonating mid-air. The sky cracked open, and the shockwave flattened forests, collapsed roofs, sent drivers careening off roads. And that was a small one. The Tunguska event in 1908 flattened 800 square miles of Siberian forest. We got lucky both times. They hit nowhere. Next time, we might not. Impacts come from above, but the Earth generates its own impossible lights. Before and during earthquakes, strange illuminations sometimes appear in the sky. Earthquake lights, flashes, glowing orbs, sheets of pale light rippling across the horizon. Documented in 2009 in L'Aquila, Italy, and in 1965 in Japan during the Matsushiro earthquake swarm. The leading theory? Tectonic stress ionizes gases escaping from fractures in the Earth's crust. Pressure building for decades, suddenly released, ripping open the ground. and the ground itself glows. The Earth announces its breaking. And on even rarer occasions, the cosmos announces the death of a star. A naked-eye supernova, a stellar explosion close enough to be visible without a telescope, bright enough to cast shadows at night. The last one occurred in 1987 over the southern hemisphere. In 1054 AD, Chinese astronomers recorded a guest star visible in daylight for weeks. It left behind the Crab Nebula, still expanding today. The next candidate, Betelgeuse, 642 light-years away. It's already dying, its core collapsing. It could explode tomorrow, or in 100,000 years. When it does, we'll have two suns in the sky for weeks. A star dies, and for a moment, the night ends across half the planet. And now, the bottom, where reality and myth blur. Layer 6, mythic/contested. These might be real, or they might be stories we tell in the dark. No definitive video, no controlled observation, just reports. Supernovae kill stars light-years away. But here on Earth, travelers in centuries past reported something far smaller, far stranger, that killed in a different way. In the 18th and 19th centuries, people crossing swamps and marshes at night spoke of lights, will-o'-the-wisps, ghostly, flickering, beckoning. Folklore said they were spirits of the dead, luring travelers into bogs where they drown. The scientific theory makes sense. Methane gas from decaying vegetation spontaneously ignites in air, creating dancing flames. Plausible, testable, except for one problem. When we drained the swamps, the lights stopped appearing. We destroyed their habitat, and the phenomenon went with it. Were they ever real, or were they always just stories told by exhausted, disoriented travelers, seeing what fear suggested they should see? Swamp lights may be myth, but thousands of people across centuries have reported something far more disturbing. Ball lightning. A glowing sphere 1 to 2 feet wide, lasting anywhere from seconds to minutes. It floats. It moves through walls. Sometimes it explodes. Sometimes it vanishes silently, leaving only the smell of ozone. Pilots have reported them appearing in cockpits during thunderstorms. People claim to have seen them roll across floors, hover in corners, move with seeming intelligence. Scientists have created plasma balls in laboratories, but those last milliseconds, not minutes. They don't pass through solid matter. They don't navigate around furniture. Thousands of eyewitness accounts spanning continents and centuries. Almost zero definitive footage in the smartphone era. Every time someone tries to film it, it vanishes. Or the footage is blurry, inconclusive, possibly faked. Is it real? A rare plasma phenomenon we simply don't understand yet? Or is it the brain misfiring under the trauma of nearby lightning strikes? A hallucination born from electrical interference with our neurons, creating false memories of impossible things. We want it to be real. We desperately want nature to have one more secret, one more mystery. We just can't prove it. If ball lightning exists, it's electromagnetic. But there are reports of something even stranger. Light generated not by lightning, but by the tornado itself. Blackwell, Oklahoma, May 24, 1955. A violent tornado carved through the town, and multiple witnesses, people who had no reason to coordinate their stories, reported something that still haunts researchers. The tornado glowed, green and blue light emanating from the funnel itself, not from power lines, not from fires, and worse, orbs of light rotating around it. Satellites, moons, orbiting the funnel like debris, but made of light. Possible explanations exist. St. Elmo's fire on debris within the vortex, ionized air clinging to fast-moving objects, power lines torn down, sparking in the rain, triboelectric effects, dirt and debris colliding at such speed that static electricity builds and discharges, or mass hallucination, the brain inventing light where there was only darkness and terror. But the witnesses were consistent, and they described the same thing. The tornado glowed, and light circled it. If it's real, if tornadoes can somehow generate light through electrical discharge, through particle collision, through mechanisms we don't understand, then it's the most terrifying natural phenomenon ever documented. A tornado that glows in the dark, with satellites of light marking its rotation, if it's real. And then there are the lights that appear nowhere near storms. Ghost lights. Marfa, Texas. Brown Mountain, North Carolina. Hesdalen, Norway. Lights that appear on the horizon, dance for minutes or hours, then vanish. They've been reported for over a century. Theories abound. Car headlight refraction, though reports predate automobiles. Piezoelectric effects in quartz-rich geology. Tectonic stress generating electricity. Atmospheric mirages bending light from distant sources. Bioluminescent gases. Plasma balls. Ball lightning's cousin. None of the theories fully explain why these lights appear in the same specific locations year after year, century after century. Native people spoke of them before colonization. Modern researchers film them with high-speed cameras and still can't explain them. They appear, they vanish, and no one knows why. Layer 6, where science ends and stories begin. But every myth starts somewhere. Every impossible thing was once just a story, until someone proved it real.
From blue sky to glowing tornadoes, these all exist on the same spectrum. A continuum of rarity, stretching from the everyday miracle to the impossible made real. Nature doesn't care about rarity. A tornado doesn't know it's rare. It just is. The universe isn't trying to show you wonders. You just happen to be here when they occur. Or you don't. Tim Samaras spent his entire life chasing the rarest storms. He dedicated decades to understanding them, developing instruments to measure them, teaching others to respect them. And the rarest storm found him. Every phenomenon on this list is indifferent to whether you witness it. The green flash doesn't care if you blinked. The fire tornado doesn't pause for you to take a photo. Ball lightning, if it exists, owes you no proof. The iceberg doesn't end at layer 6, it just fades into black. And somewhere in that black, in the crushing deep where no light reaches, something is happening right now that has no name. A phenomenon so rare, so fleeting, that it will occur and vanish without a single witness. How deep did you get? Comment your deepest layer. If you've seen crown flash, fire tornado, earthquake lights, or ball lightning, tell your story, because these aren't just phenomena, they're experiences, and every single one changes the person who witnesses it. Nature is not a museum, it's not a catalog, it's a dice roll, happening every second of every day, in every corner of this planet. And every day you're alive, the dice keep rolling.